we're going to learn calculus from Thomas Calculus book, Global Edition, 15th edition in SI unit. Okay, so what's in the first chapter? So in chapter 1, so we talk about functions. 1.1 has functions and their graphs. 1.2 is section 1.2 is combining function shifting and scaling graphs. 1.3 talks about trigonometric function. 1.4 talks about exponential function, inverse function and logarithmic function. So let's start with function and their graphs. So it can take input and do some mechanism here and gives some output. For example, in coffee machine we can input coffee, water, and the machine will give us coffee. In mathematics, the function written as f of x, f is a function of x. We read as f of x, simply f of x. This can be written as y is equal to f of x. So we read this as y equals f of x. Y is equal to f of x. X is variable and y depends on it. So if we change x, this should also change y. So x is our independent variable. So x is independent variable and y is dependent variable. So y depends on x. So what's the definition of function? So for example, we can write y is equal to x square, or y is equal to f of x is equal to x square. Here x is independent variable and y is dependent variable. So what's the formal definition of function? A function f from a set D to a set Y is a rule that assigns single value f of x in Y to each x in D. So this seems a bit much to grasp. So D is our input set and Y is our output set. D, let's say this is space our D. D stands for domain. So here is our space of Y. So D is all possible input, all possible input values for x. So if here is the rule, which rule to follow, and its value corresponds to its value in the y. So set of all possible output values f of x. So this is our range. So if we pick a point like a point A, then this should corresponds to a point, let me use different color, which is f of a. So let's calculate some domain and range of some different function. So y is equal to x square would be a great example. So here is our function Here will be our domain, range. So which is y, domain is x, y is equal to x square. Real number would be our domain. For input we can use a number, so from minus infinity to plus infinity, so any number possible we can input here. What these brackets mean I will explain later. The range would be from 0 to positive infinity. How this can be seen? So let's make a table. So x, y is equal to f of x is equal to x square. So x is 0, then y is 0 square 0. If x is 1, positive 1, then y is 1. If x is 2, then y is 4. Similarly 3, 9. What about the negative number? So if we take negative 1, we get positive 1. Minus 1 is square, which is just positive 1. Minus 2, which is 4. So as we can see that this, from starting to 0 we can get up to positive infinity, we can get any kind of number. So our range is y. So let's talk about real numbers and real number line. In our number line, in middle we have 0, and the left side we have minus 1, minus 2, minus 3, and so on. In between, so we have negative 1 over 2. On the right side we have positive 1, positive 2, 3, 4, and so on. Somewhere here we have pi, which is 3.1415, and so on. The right side limit. So we can imagine the largest possible number. The right side of the real line extends to positive infinity, so largest number possible, and the left side of the real number extends to negative infinity, which is negative infinity. And somewhere between here we have square root of 2, which is also real number. Let's talk about intervals. We have finite interval, infinite interval. So let's understand some intervals. So we want to talk about this interval minus 2 to plus 2. So let's put first bracket, which is equivalent to minus 2. Some book uses this notation. So in this number line, this is our 0, minus 1, minus 2, and plus 1, plus 2, 3, minus 3. So here we can see that this is from minus 2 to plus 2, but neither of these values are in this interval. Starting after minus 2 up to plus 2. So this is our open interval because the endpoint is not included in the interval. Endpoint is not included. Let's see another example. Minus 2 to plus 2. Let's from minus 2 to positive 2, but 2 is not included. So in number line, this is our 0, minus 1, minus 2, minus 3, 1, 2, 3. So here minus 2 is included. So from including minus 2, up to positive 2. This would be our interval. This is half open, half close interval. So half open interval, because one endpoint is open, one endpoint is not included. So as you can guess, the close interval would be from -2 to +2, both endpoint included. So this is our number line: 0, -1, -2, -3, 1, 2, 3, and yeah. So -2 to +2, and this value to this value, both are included. So what about -2 to +infinity? We cannot really go to the largest possible value, which is infinity, because we cannot reach infinity. So what would be, so this is not correct, this is wrong. The correct one would be like this: 0, -1, +1, 2, and so on. And this side would be -2. So including -2 up to the largest value possible. We just learned interval. So why the range is 0 to positive infinity is because if we put negative number in the x square value, this would give the positive number. So the range would be from 0 to positive infinity. What about y is equal to 1 over x? 1 over 0 does not exist because we can divide by 0. So we cannot take x0 as input, but from minus infinity up to 0, and so this is union, is just summation of two set. Then starting after 0, we can go up to positive infinity. What would be the range? The range would be, so no matter what, we cannot get y is equal to 0. So the range also would be minus infinity to 0 up to 0, union after 0 to positive infinity. So what about y is equal to square root of x? So we know that square root of x, we cannot have negative number, so x have to be positive or greater than 0, but 0 can be included. So the range is from 0 to positive infinity. So the domain would be from 0 to positive infinity, the allowable value of x, and we can say that this, for this input, this number should give 0 to similarly positive infinity. Range would be, okay, let's, how about y is equal to square root of 4 minus x? So as we can, so we know that negative can be inside square root. 4 minus x have to be greater than 0 or equal. So if we add both sides of the equation plus x, 4 minus x greater than 0 plus x, we get 4 So x has to be less than 4. So how this looks in number line? So in number line, this is 0. Let's say this is plus 4. So including 4, any smaller number than 4. So yeah, like this. So the domain would be from minus infinity, including up to 4. Yes, and the range would be, we can see the range is, if we seen previously, the range always be from 0 to up to infinity. Can this be infinity? I guess if we take really negative number, this can go. So let's consider another complicated one. Y is equal to square root of 1 minus x square. So 1 minus x square has to be greater than or 0, and you can see that if we add both sides of the equation, 1 minus x square, 1 minus x square plus x square, so x square has to be less than 1. X has to be from minus 1 to plus 1, and then we can say that the x square is always smaller than and equal to 1. So this is our domain. So minus 1 to plus 1, but can we take 1? Yes, we can, because 0 is allowed. So this is our domain. What about the range? So to calculate the range, let's see here. So if we take maximum value of x, which is 1, so y of 1 is square root of 1 minus 1 or 0. Y of minus 1 is similarly 0. What about y of 0? Y of 0 is square root of 1, which is 1. Okay, so as we can see, the range cannot be greater than 1. So from 0 to 1, this is our range. So yeah, let's move on. By the way, this was example 1 of the Thomas's book. So we just verified all the domain. Graph of function. Let's move on to the next topic. So graph is in Cartesian plane, the x-axis, y-axis. Let's consider a function like f of x is equal to x plus 2. What would be the graph in this function? Let's make a small table here, x and f of x. For x is equal to 0, we get f of x is equal to 2. So at 0, we get 2. So 1, 2. So we get 2. Let me use a different color pen. X is equal to 0, we get positive 2. So x is equal to 0, we get positive 2. This is our value. Similarly, for x is equal to 1, we get 3. For x is equal to -2, we get 0. X is equal to -1, we get +1, and so on. Let's put this point here. So the coordinate of this point is So the coordinate of this point is 0, 2, 1, 3. So 1, 3. This is our next point. 1, 3. -2, 0. -2, 0. This is our next point. -2, 0. And -1 is 1. So -1 is 1. So if we add those points continuously, the graph should look like, so this is the graph of f of x is equal to x plus 2. Similarly, we can show the graph for y is equal to x square would be, this is our x-axis, y-axis, like this. Let me use different color. Okay, like this. So for 1 is equal to 1, the value is 1, 1. And for 2 is equal to, the value would be 4. So 2, 4. Similarly, here we have -2, 4. So x is equal to -2. We get y, the height is 4, and so on. So this is the graph of y is equal to x squared vertical line test. For a function. Not every curve in the coordinate planes can be the graph of a function. So why is that? Let's check some graphs. XY plane. This is our XY plane. So let's draw a circle. So unit circle. So this is our +1, x is -1 here. So we draw a vertical line, and we can see that for a single value of x, we get two different height, two different value of y. So this is not a function. So circle fails the vertical line test. So circle is not a graph of a function. Let's look at another example, the semicircle. So if we draw a vertical line for single value of x, we can see there exists only single value of y. So this is a function, and so we can write the upper semicircle is a graph of a function. The function is y is equal to plus square root of 1 minus x square. What about the lower semicircle? Plus 1 minus 1. Okay, so let's draw a vertical line. So we can see for single value of x, we have single value of y. So this is also a graph of function. Is a graph of the function y is equal to minus root over 1 minus x square.